Hello, this is Bryant Myers. In this video, we are going to clear up some misconceptions of flat earthers regarding curvature. And the two big misconceptions here, as we'll see in this little animation, is that curvature can be seen in two different directions. We can see the curvature looking forward when a ship goes over the horizon. Or there's many great videos to show even larger like boats going over the horizon, very convincingly showing the Earth curvature forwards and backwards. And no amount of zooming, contrary to what flat earthers say, is going to bring back ships that are already over the horizon. The P900, the P1000 cameras will bring ships into focus that maybe were obscured by visibility or distance, but if the ship is already over the horizon, no amount of zooming is going to bring it back. So that's forward and backwards, and this forward-backwards curvature can be seen as a dip in the horizon, meaning it's an up and down vertical dip. Now the other type of curvature is a back and forth type of curvature from side to side. And this type of curvature you can see by going to high altitude, and you must use a wide angle camera. So the ground level curvature, like the ship going over the horizon, we need to use a zoom telescopic lens, a very narrow screen, so we're not going to see the side to side curvature there, but we will see the up and down curvature as the ship goes over the horizon. So let me just play this little animation because it's going to really explain it very nicely. And the other thing I like about this animation is it really epitomizes what science is all about. We know how big the Earth is, so we can create a model, in this case an animation, a very precise mathematical model that will show us just plain geometry. It shows us at different elevations what the curvature should look like, and then we can go to those elevations as an experiment and we can see if those shots of the horizon, showing the curvature, will match our model. And as this great animation will show, you're going to see that it does. Flat earthers have no model. The best they can come up with is something like the horizon meets eye level, and not even that is right because the horizon falls below eye level as you go up in elevation. So they don't have any equations, they don't have any science, they don't have any models. They just have a belief system, a philosophy, and they use a lot of ad hoc explanations to try to justify their model, but they don't have an actual scientific model that can be tested. So here we're going to see how science works, where we do have a model and we can test it, and we actually see the curvature as expected by the model. Very, very convincing. So let's go ahead and start the animation here. So we're going to start at sea level. So from side to side, as you'd probably expect, there's not going to be a whole lot of visible curvature, even with a very wide angle lens. And that's because the Earth is huge. It's like 8,000 miles in diameter. So we're just not going to see any curvature. But now if we go up to 500 meters, now it's still looking pretty flat. But if you can get up this high and you have a really good camera and you use something like a level, you can actually see a few pixels of curvature. It's not going to be dramatic, but you can almost see something. But again, at 500 meters, you're just not going to see much of a curvature. But what you do see at 500 meters is a dip in the horizon. Again, the horizon does not meet eye level. Again, flat earthers don't have a model. They just have a bunch of expressions and sayings. And this one is provably wrong. The higher you go up, the more the horizon dips. It does not meet eye level. Now let's go up to a plane altitude, a cruising altitude around 33,700 feet. Now at this level, if you got a wide enough angle of view, you can see a little bit of curvature from even a commercial flight, but it's not going to be dramatic. Why? Because the Earth is 8,000 miles in diameter. It's very, very large. So here we are looking at an actual picture from a commercial jet, and it turns out that the slight amount of curvature actually perfectly matches our model, as you can see. Again, the graphics here are modeling a sphere roughly the size of our Earth, and the slight curvature that we notice on the commercial jet will match that precisely. Again, great confirmation that our model is a good, accurate model of reality. And look at how much the horizon is dipping now. This is why pilots can see like mountains or cities come into view where they were hidden before. You can't get that on a flat Earth. Things just shrink. So now we're going up to a higher elevation. So now we're at 30 kilometers. This is going up very high. And at this elevation, you will be able to definitely see the curvature. Some high altitude balloons will even go a little bit higher than this. And as long as you center, this is a key here, you have to center the camera on the horizon. Otherwise, you're going to get some skewing up or down. But if you do it right, you can get a very accurate picture, and you can see the curvature here. Now, what some flat earthers do with these high altitude balloons is they take the shots when the camera is a little bit below the center, and that gives a little bit of a convexity to the image, which will flatten it out. But that's not accurate. If we really look honestly, and by putting the camera on the center, even with the fisheye lens, even if the curvature is distorted, it's not gonna, if it's flat, it would still be flat. So we can certainly use a rectilinear lens and get rid of any fisheye distortions. But the point is if you're really zooming the camera at the center of the frame, if there's curvature, there's curvature. And again, if we have the right type of camera, we won't get any types of distortion. But again, at this level, it's very obvious to see Earth curvature. And the old Concorde jets would go up to 60,000 feet, and the passengers could easily see the curvature there. So now let's go up to the ISS. Okay, this is the International Space Station, and curvature is just obvious here. And of course, flat earthers will cry that it's the windows or whatever, or the glass windows are convex, but that's just not true. So now we have the Tesla from space, the first car to ever orbit the Earth. And in this picture, we can see Elon Musk's Tesla 4,000 kilometers in altitude, even much higher up than the ISS. And the curvature is very striking from this distance. And sure enough, our model accurately shows the curve as it appeared from the pictures from Elon Musk's satellite. So you almost have to go to the moon or really get far out to see the whole spherical Earth in one frame. And contrary to what flat earthers say, we do have many images from the Apollo missions, and even more recently with other satellite launches, of the full Earth from space without any type of CGI, without any type of stitching together different images, which you can do with satellites. But we do have actual pictures of the full Earth. So again, thanks for watching this video. Many more to come. My goal is to really debunk flat Earth and to show people that the beauty of our spherical Earth is much more inspiring anyway. It turns out reality really is much more interesting than science fiction here. Thanks, and have a great rest of your day.